Good afternoon. So you decided to stay till the end. You must be tired after such a long day of really nice talks. And I'm really glad that you actually came here because it is almost one of the last talks during this day. And yeah, let's go. Did you know that business process management market is currently worth around $8 billion? And I can tell you even more. By 2025, it will be worth around $18.5 billion. Why would companies invest such incredibly huge amount of money into BPMS? And the answer is pretty simple, actually, because business processes are what define how our companies make money, how they are competitive, or simply how they live in the complex world of legal regulations. And wherever we come from, our companies are pretty much the same. They want to earn money and reduce their costs. That's why they try to optimize and automate their business processes. And they often do it just by buying an off-the-shelf solution, a ready product. And there's completely nothing wrong about this. At the same time, though, we developers are often used to follow agile software development principles. We know how to utilize domain-driven design, microservices, to actually deliver products of higher quality and deliver them much quicker. The question now is, how can we reconcile business process management systems with the idea of microservices and agile software development? During this presentation, we will together try to find the answer to this question. We will also see how tools from Spring ecosystem will help us achieving this goal. This talk will be a bit different, probably, from all the others that you've been during this conference, because I would like to keep this on a high level of abstraction, not digging too deep into the technical details of each tool. I want you to get the general idea and understand the approach that we can take in order to find the answer. And my name is Bartłomiej Słota. I come from Warsaw, Poland, and I also come here to you as a person that spent around 4 years automating business processes, both for custom solutions and off-the-shelf ones as well. And I've been there. I've went through the good and through the bad sides of this kind of systems. And today, I'm a consultant at Bottega IT Minds, which is a Polish company. And with the consent of our client, I can actually share with you some details about what I'm doing professionally today. And I currently work for Vattenfall, which is a Swedish power company, whose mission is fossil-free in 1 generation. And Vattenfall is also e-mobility services and infrastructure, including charging stations for Tesla or other electric vehicles, and of course, web services for the users. And within the last few years, the cooperation between Bottega IT Minds and Vattenfall IT Services in Katowice, Poland, resulted in a 5-time increase in the number of available charging stations. And today, we are in the progress of migrating the mobility platform into new microservice environment, running on Kubernetes clusters in Microsoft Azure Cloud, and tools that we are using on a daily basis include Java 11, Spring Boot, Apache Kafka, and this is another reason why I'm standing here in front of you talking about microservices. It's been over 3 years already since I started working with microservices professionally. And before we get into the main topic, let's meet Bruce. Bruce is a software engineer. He has like 7 years of experience. He's been working on automating business processes for quite some time already, and he's very passionate about microservices. He goes to conferences just as we do. He reads books. He's very fond of domain-driven design, and you know what? He struggles a lot in his project. People are quitting the company, are very frustrated. It's very hard to produce a single change in the system. It's even hard to find the line in code that should be modified in order to provide this change. They cannot find the common ground with business people. But Bruce is not like all his colleagues. He wants to stay in the company, and he feels that microservices can actually help him and his company to save the project. But he has no idea how to apply the idea of microservices into BPMS. And we will try to help Bruce out with his problem. And Before we do so, we need to know what microservices are all about and what BPMS are all about. You won't hear from me any vendor-related stuff. We'll just do microservices. All right. If you ask Bruce what microservices mean to him, he would tell you something that I told him like hundreds of times. Microservices are all about the autonomy. What is the autonomy? Autonomy is multi-dimensional vector consisting of 6 dimensions. The most important one is scalability. We scale our services for numerous reasons. For example, we may need to deal with a bigger load, the traffic is getting higher, so we may scale our services vertically by adding new resources like CPU or memory, or we may scale our services horizontally by adding new instances of our service. Another reason for scaling is that we want to be resilient in case of failure. And then vertical scalability won't give us much. We usually just add new instances. But what I really want to tell you is that scalability is not only about technical stuff. Application in its lifetime might get to the moment where the size, the complexity, the technical depth might reach such a high level that the system won't be scalable from organizational or cost perspective. And such example is very well described by Uncle Bob in his book entitled Clean Architecture, when he actually describes the real company and tells about some measures, some indicators about how things change release by release. And what you can see here on the first figure is that the number of engineers that are required to develop and maintain the product is drastically rising, release by release. At the same time, the number of lines of code, lines of code that are being written in every iteration is decreasing, which means that the unit cost of a single business line of code is getting higher and higher. The more people we have, the least code we write, the lower the productivity is. And what our CEO sees now is that our IT department no longer costs like $1 million. It costs like $20 million. So you can see how crucial it is to take care of organizational scalability as well. And regarding the autonomy, each part of our system, each component should be scalable independently, just as our organization does. So here's Bruce. They're struggling a lot in producing any single change. There's frustration, there's productivity is very low, so we need to help Bruce out in this area as well. Another dimension of the autonomy vector is deployment. The way each microservice is being deployed, including deployment frequency, should be an individual decision of a team that actually is responsible for this particular service. Of course, we usually aim for having like a consistent deployment schema throughout the company, throughout all our teams. But there might be components like ACLs, for example, or components that are working under strict legal regulations that need to follow some other unique software development lifecycle. But anyway, how to provide deployment autonomy? We need to make our services as independent as possible. How to provide this independence? Through high cohesion, providing high cohesion. And in a nutshell, it means that the logic microservices contain must be concentrated on concrete business functionalities and not leak to other services. Microservices are not only about the code. These are databases as well. And each microservice should manage data itself. Should manage the data it's responsible for itself, securing the access to database and not allowing any other service to actually access the schema or modified data. And dividing our business into parts lets us choose technologies that are appropriate for the complexity of the problem that we are currently solving. We may use different set of technologies for complex business logic. We may use different set of technologies like, for example, Spring Data REST for CRUD applications. And at the same time, we may also experiment with new technologies in some single services, not impacting the whole system, so that we can be more competitive in the market. In the world of distributed systems, failures are inevitable. They will happen. So why would accounting module, for example, failure block the possibility of reading charging sessions of my Tesla, right? The autonomy is also the autonomy of failure. Each microservice that fails should impact other services in the smallest possible extent. And finally, nothing would have happened if it hadn't been for people. Microservices can only work in places where the organizational culture is ready to give teams the autonomy, the possibility to take care of the product end to end from the very beginning, from the first analysis throughout the whole life cycle. And they need to let the leadership in each team to show up itself. There is no place for command and control. How many times were you angry at how things work in your project, how things are communicating between each other? We are getting frustrated very often, right? And it didn't happen just like that. According to Conway's law, the man over here, every organization will eventually create a system that mirrors communication schemes from the company. And we developers often tend to ignore business. We know how to write the code. We don't need to talk with them, right? And do you know what happens with this ignorance? It is put into the code, committed, and pushed to Git. What should we do instead? Instead, we should talk with these people, try to find the common ground, try to find out what are the real business processes, where's the value, where do we earn money, where do we lose money, etc. And only when we are on the same page, we can really create real bounded context and thus provide truly cohesive microservices, autonomous microservices. And that's why we should advise Bruce to start with event storming. Event storming is a workshop-based method for exploring business domains, business processes, and it is incredibly engaging, effective, easy, and fun as well. Big picture event storming session, which is one of the possible variations of this workshop, gathers people from different areas, stakeholders, business people, analysts, architects, developers, QAs, whoever can have some insights into the problem that we are currently working on. And leaving the room after such workshop, every participant has the same level of knowledge. During this workshop, we all can understand where is the real problem, how the business process looks like, what are the business rules that drives the process, where we lose money, where we gain money, where we gain reputation, where we lose reputation, what are the problems, what are the priorities. And it also gives us the base for further work, like design-level tactical sessions, where we can actually get the meat for us, the aggregates, the entities, the domain-driven design, building blocks, etc. But why we are talking about this in terms of business processes? Because in every company, people tend to do two things. First, do their job well, which is naturally good. And second, ignore what happens outside the team or the department. And this ignorance, like we already mentioned it, is very dangerous, as we might lose the big picture and don't know how things influence each other. So this is how silos are born. And business in every organization, mine, yours, and yours in the back, is the same. And it's never restricted to one type of operations in one silo only. Business always crosses silos, always. It means that there's no single point of truth in terms of understanding the business process. And it is also a source of confusion because people from one department, from one silo, might use different definitions of the same term than all the others. Summing up, a business problem is hard to solve, hard to discuss, and hard to visualize. And it is event storming that enables us to overcome all these obstacles and work out the common vision of the business process that won't be based on some UML or BPMN diagrams provided by analysts. It will be a living source of knowledge. And similarly, the business process implementation might cross different teams, different microservices. They need to communicate somehow with each other. And Bruce really needs to start in here to actually understand why does he have the mess in the code and understand what system he's currently doing and what it is supposed to be doing. And he knows where to start. He knows what microservices are all about, but he still has no idea about how to apply microservices to BPMS. So let's ask Bruce what BPMS is all about. And at the very high level, most BPMS systems consist of following parts. Of course, this is just a general high-level overview. There might be some other components as well, but let's keep it simple. In the heart of each BPMS, there's a thing called workflow engine. You can treat it as a black box that is just responsible for process execution, including human tasks, service task execution, access control, managing process metadata, etc. But the part that business is really looking for are those fancy UIs. They buy it with their eyes. They need to have a common view that actually eases their work, will help them in their everyday life. And next valuable thing are reports. Business needs to know how the processes are performing, if they're earning money or if they're losing money. There are also process modelers where we can actually model the process with some standard notations like BPMN notation, and also some system integrations, connectors that actually enables us to integrate the BPMS with all the other parts in our system. This is kind of a high-level overview. Let's take a look at the architecture then. Don't worry, I will zoom it in. These are, of course, again, this is a very simplified view. There might be much more blocks, but let's keep it simple. The user interacts with the system through some fancy UIs, and let's say that it eventually ends up in some kind of UI controller. What UI controller does is that it forwards requests to modules usually within a monolith, like history and audit, reporting, user and access management, human task component, task list, and all task-related stuff ends up in workflow engine. And all of these components actually use common, usually relational database to persist the state, persist the data. The question now is, does this architecture align with the autonomy we've been talking about? Let's try to find out. Do we have scalability autonomy? We don't. We either scale a whole system or we don't scale at all. Do we have technology autonomy? We don't, because we are constrained to use the same set of technologies within all business processes. Do we have deployment autonomy? We don't. We either deploy the whole system or we deploy nothing. I know one system actually that allows us to deploy processes independently, but underneath there's still the same set of resources. So if anything goes wrong, we either get deployment autonomy or resilience autonomy. Do we have data autonomy? We don't. Every business process uses the same generic database, generic schema, same tables, and it's even very hard to extract the data related to one particular business process. And in terms of people autonomy, teams are usually working on common code bases. They need to schedule deployments, constantly merge their changes, resolve conflicts. So these kinds of systems usually do not apply to the core idea of microservice autonomy. And if you have any knowledge of any off-the-shelf solution that applies to this, just let me know. How Bruce, as developer, might perceive it. Bruce is very sad. And he's sad not only because this architecture from BPMS does not apply to the microservice autonomy. He's also sad because his work is very often manual. In order to provide some change, he often needs to manually click through some UI management console to actually create a view, a form, or something. He also needs to make some dirty hacks sometimes to make things work. And he cannot even bump up the Java version from 7 to 8. He's technologically constrained. But as we advised Bruce, he ran a quick event storming session with his colleagues for one of the processes that is actually present in their company. And the process is called address change. Let's have a look how it works. Whenever a customer calls call center and requests the address change, the call center employee attempts the authorization. So the customer needs to provide some customer password, and if it's correct, the address change gets authorized, the address change is registered, then the IML, anti-money laundering process, is getting started, and based on the result, whether if the IML check is positive, then we confirm the address change, or if it's not, then we recall the address change. And because Bruce is very fluent in BPMN, he quickly sketched a diagram that corresponds to what we just modeled with sticky notes, with the difference that this diagram might not be readable for everyone, while sticky notes are readable for almost every person on Earth. These are just sticky notes written by a human with a pen. Bruce made also enough analysis to assume that there will be 3 microservices. Authorizer, that will be common for most business processes and will be responsible for authorizing customers that are calling the call center. Customer contact, responsible for managing customer contact information, and AML, anti-money laundering related processes. These services need to communicate somehow, and of course there are numerous communication patterns that might even be mixed within a company, but we want to keep our services as autonomous as possible and as decoupled as possible, so we will just stick to asynchronous versions, to asynchronous options of communication. What asynchronous options do we have then? The first one is choreography. How does it work? Well, choreography assumes that there is no central point in the system that would route messages among services and decide which message should go where. Instead, services emit event messages and don't care what happens next. On the other hand, consumers read those messages and take further actions. And this pattern is called event chain. Choreography in our case will look like this. The client emits the address change requested event to the event bus, authorizer consumes it. We will only analyze the successful path, okay? The authorizer sends back the address change authorized event. This event is consumed by customer contact. Customer contact says that address change was registered. Address change registered is consumed by AML. AML returns the AML check succeeded. This is again consumed by customer contact, and address change confirmed gets back to the client. In general, choreography is a great way of communication. But in case of business processes, we can identify some problems. What are they? Authorization service listens to address change requested event, which is business process related event. So anytime we want to add a new business process, authorizer would need to be modified. And clearly, hypothetically, someone could say, why don't we use some generic event like authorization request? Then we wouldn't need to modify anything. Okay, but if we, in general, events should mean something to business. Does authorization requested mean anything to business? In our case, clearly not. Maybe you have any cases where it does. Anyway, authorization requested message, let's call it a message, is dedicated to one particular service. It's no, any other service is not supposed to read this. So it's a direct message. And what's more, it is an imperative because we want to perform an action. So it's not an event, it's a command. It would be a wrong usage of event message pattern. But this was just a hypothetical discussion. It depends on the real use case. Anyway, yet another problem we may spot here is that customer contact needs to be aware that there's some AML process going on up there because it needs to listen to AML check succeeded, AML check failed events, right? So whenever we want to change the order of steps in our process, we would need to modify both of these components. Do we have any alternative then? Yes, we do. The orchestration, which is nothing more than just event command transformation pattern. And this is how it works. The client sends the imperative command to address change process, and the address change process is actually a new actor in our web sequence diagram. And the address change process is an orchestrator, business process orchestrator. His role is to make decisions what should be done next, which command should be sent to which service. And the client sends the imperative command to address change process. This in turn is sent through the message bus to authorizer, authorize address change. The authorizer sends the event back, and orchestrator reads the event and makes the decision what should be done next. And the next step is to register the address change in customer contact. And so he sends through the message bus, through some specific channel, a register address change command to customer contact. Then it responds with an event again. Another command goes to AML, AML responds. Another command goes to customer contact, and the response gets back to the customer. And do you know what Bruce asked me? Can we join process orchestrator, address change process, with customer contact? And the answer is yes, we can. according to hexagonal architecture, the business logic should be independent from application and infrastructure layers, which are actually implemented within the address change process. But it is not always that simple that we can actually map the process orchestrator with a business service one-to-one. How do we know if it's possible to join these components into one? Actually, it should be available to us after event storming session, where we could identify the core domain. We'll get back to it soon. Yet another question from Bruce. What, if anything, wrong happens here? Right? Here's kind of a transaction, right? Do we need to store the state in the address change process orchestrator? And clearly, theoretically, we don't need to process the state. We could use routing slip pattern and send another steps which should be taken in message headers, for example. But clearly, practically, and pragmatically, we would rather use process manager or saga pattern. And this is what we have here. We have a saga. Address change registered starts our transaction, opens the transaction, and based on the result from AML, if the address change is confirmed, we commit the transaction, or if the AML check is negative, then we recall the address change, we roll back the transaction. And regarding the persistence and the engine of the orchestrator, we may have numerous options. We can use relational databases, we can use actor model, we can use finite state machine, we can use some custom solutions. And yes, we can also use activity, for example. How does it look like from architectural perspective? I will zoom it in, don't worry. The green components are microservices that are common to all other business processes, while the green ones are business process related. Imagine this is green. The flow is pretty similar to what we've seen with BPMS. The user interacts with our system through some fancy UIs and ends up in UI controller. What UI controller does is it forwards commands through Apache Kafka into our process orchestrators, like address change process, and forwards requests to our common components like history, task list, reports on user or user and access manager. What is interesting here is that these components, they create read models for UA controller by reading events from address change process, from process orchestrators. Doesn't it sound like CQRS? It is CQRS. We are sending commands here and emit events, process-related events, which are consumed over here in order to produce read models. This is CQRS. And interesting is also the component on the right, user and access manager, which was part of the same monolith before, and now is separate from the process orchestrator. Why is it okay? Because process orchestrator does not care about how the authorization part is actually implemented. The only thing he needs to know is which user is actually trying to perform some action. What happens next is that the address change process, the process orchestrator, sends command further to business microservices like authorizer, customer contact, AML, and reads events that they emit. And each microservice manage their own data in their own databases with their own schemas, etc. And I mentioned Kafka. And Bruce knows Kafka a lot. He knows its performance style, all its advantages, but he wonders why it is good in our case to use Kafka. How can it help in our case? Well, and we can actually find at least 3 reasons for that. First of all, consumer groups. Our process orchestrators can listen to events not competing with any other listeners that might be somewhere here. It won't interrupt any choreography that is happening over here. It will be acting within its own consumer group. That's the first thing. Second thing is scalability, backed by topic partitioning. If we have like 10 partitions for a topic, we may have up to 10 instances of our process orchestrator. And finally, Kafka Streams, which is a fantastic tool for building streams and views, and we'll get back to Kafka Streams as well. Bruce has another question. how can we deliver new business process? Do we always need to modify these common components like task lists, history, and reports? If we would need to modify them every time, we would rather have a distributed monolith rather than microservices. So the answer is rather use convention over configuration. What I mean by this is that we could establish a set of generic events that would inform us about in which possible state the process currently is. To be specific, what kind of events could be? Process instance created, process instance cancelled, task created, task assigned, task completed. So, thanks to this, we leave ourselves an option to choose the different orchestrator engines, to experiment with them. We may use simple if-else statements. If the process is very simple, we may use Akka, we may use activity, or any other engine we like, just following these conventions. And a question from Bruce: who will control this convention? A team will, because a team is responsible for the process end to end. And a team won't be happy if their process is not visible in the history or in the task list. So we do take care of it, believe me. Good. Another question from Bruce: how would you implement the orchestrator? And I would suggest using Spring Cloud Stream. There were at least 2 talks mentioning Spring Cloud Stream this morning, so I won't dig too deep into details. But in a nutshell, Spring Cloud Stream is a library providing an abstraction over messaging middlewares, like Kafka, for example, enabling declarative defining of communication channels, which you can see actually on the slide. What our orchestrator does is that it communicates, it listens to commands on address change process channel topic, and it emits events on generic process events topic. And business services also have one topic, one channel for emitting events, one channel for listening to commands. And what's more, Spring Cloud Stream has also fantastic support for testing such communication, automatic testing. And it is also supported by distributed tracing library, Spring Cloud Sleuth, and contract testing from Spring Cloud Contract as well. So Spring Cloud Stream is an invaluable tool from Spring ecosystem in this kind of solutions. Bruce is still not satisfied and asks, how would I know that this particular event emitted by one particular business microservice is actually related to my business process and not to the other, yet by another convention? What is this convention? Well, a process orchestrator sending command can enhance the message with all information that are necessary to uniquely identify the process instance. And regardless if it's a message header or if it's a regular part of a payload, it doesn't matter. It needs to be added to the message. And what business microservice does is it is just to take this header and send it back with the event. Doesn't it look similar to what Spring Cloud Sleuth does? It looks similar. Next question from Bruce. How would I get tasks assigned to user? And here comes Kafka Streams. Kafka Streams is a lightweight library built on top of the Kafka consumer and Kafka producer, and it lets us calculate stream, publish events on other topics, make aggregations, windowing, filtering, and many, many other stuff. And regarding task lists, what you can see here is that we could declaratively define how we consume the generic process events topic, how we group messages that are being sent there, how we filter them, and finally, how we build the read model. And actually, this is how we do, this is how we make read models in Vattenfall every day. We build read models in that way. We utilize Kafka Streams a lot, and it's a very powerful tool, believe me. Does this work the same way in terms of reports? Yes, it does. You can utilize Kafka Streams. You can, for example, use MongoDB or Cassandra to actually store the view, the read model optimized views. Over here, you can use Scala, you can use Spark, you can use some machine learning, and you can, with this, you get so much technical autonomy that you could produce reports that business have never dreamt of, that no vendor will ever provide you with an off-the-shelf BPMS solution. How can Bruce monitor its services? And according to the article by Martin Fowler entitled Microservice Prerequisites, before we go into microservices, we should actually provide the basic monitoring, the basic observability. So assuming that Bruce already has that in his infrastructure, we need to say that there are countless possibilities. But if we're around the Spring toolset, the very basic, a must-have library is Spring Cloud Sleuth for distributed tracing. And there was actually a talk yesterday about that. And in a big short, the Sleuth works in a way that whenever we are sending anything, any message, there's a trace ID, a span ID added, so that we can very easily trace the route of all our requests, so that we know which, for example, component in our system failed in our business process management. In order to use this to use this library, to make it useful, we need to have a central place where we can actually search for those logs. And one of the possibilities, one of the examples would be Elasticsearch logs/Kibana stack, where we can actually search for the logs. And apart from logs, we could monitor latencies between our services or dependencies with Zipkin. We can use Micrometer, Prometheus, and we can even take one step further for semantic monitoring, which is about running tests on our living production environment and checking if our critical business processes work. Remember we said that people are essential part of microservices? Who should be the owner of the process then? And we kind of answered this question a bit. Ideally, it would be best if the whole process is managed by one single team. If the process orchestrator can be matched one-to-one with some business microservice, then they can even be merged into one application, and the problem is gone. But when the process crosses multiple microservices, then we should carefully think, what is the real core part of the process? And this is where event storming helps us, because then we can identify the core domain. And in our case, in our example that you can see in the others change process, the customer contact is the core domain. The AML or authorizer, we're just supporting with generic subdomains. But this is just a clearly hypothetical discussion, because it will depend on your use cases or on your real business. But I have one message to you. Always try to make only one team responsible for the business process, because this is the only way to provide true team's autonomy. You know what Bruce asked me? Where did you get that solution from? Enterprise integration patterns. Event message, process manager, transactional client, and many other patterns that I don't even remember their names. But everything has already been identified and described years ago. We just took these patterns and applied them to our problem. Let's sum things up. We might still have common UI that the business is really looking for, but this time it no longer needs to be clicked by our backend developers. It could be developed by front-end guys, and it can be common not only for all the business processes, but for all systems we have in company, as it is ours. It does not belong to any vendor. Reports. With our technological autonomy, we can provide reports that any vendor will give us. We can have any process modeler we like that supports UML or BPMN, but it doesn't matter. The only model that will give us value will be the one that landed on the wall with the sticky notes. You know why? Because then we actually communicate with each other. We speak with these business people. We fight for the knowledge. We don't rely on just some simple diagrams from analysts, from some proxy analysts or proxy product owners. We are part of this knowledge, and this is the real model. System integration, we don't need to have any connectors there. We can use REST template, web client from Webflux, Spring Cloud Stream, whatever we like. And instead of having one black box in the form of workflow engine, we can have numerous process orchestrators, numerous black boxes, one box per one business process. Does this solution apply to microservice autonomy? Thanks to the fact that instead of having one central workflow engine, we have numerous independent process orchestrators, we may independently deploy our processes, not impacting all the others. Such approach also lets us separate the data, because each business process will manage data itself, can have different schema, independent schemas. And having such independent services executing business processes, the failure of one business process does not necessarily need to cause the global system failure. So we have the resilience autonomy. What about scalability? We can scale our services independently. The process orchestrator is a microservice. We can scale it independently from any other services, so we have scalability autonomy. Separate process orchestrators lets us also choose technology of a choice. Lets us use technologies that are appropriate for the complexity of the business problems that we are currently solving. So we may also experiment with these technologies. We may use different tools for different process orchestrators. That's why we can be more competitive in the market. And finally, people. People taking care of the process end-to-end, working on separate code bases, will no longer be afraid of producing any change, of breaking the whole system. And even if the one process depends on the other, as in the relation of sub-process, for example, we can, for example, apply contract testing so that we know that something is wrong before we go live. And even if we're live and something bad happens, there are numerous patterns to stop the cascading failures. Small processes, small services means low level of entry for newcomers, low cost of change, organizational scalability, and these are only few advantages of what we can achieve with this solution. And Bruce is now very happy. He knows the importance of business processes within his company. He knows the real pain points. He knows where the company gains value, when it loses value, when the company earns money, when it loses money, what are the business rules that drives the business, that makes the company competitive. And he applies real microservices, autonomous from the perspectives of scalability, data, technology, resilience, deployment, and people. And he uses latest technologies appropriate to the class of problem, the complexity of problem that he's currently solving. And changes are done at highest possible pace. And you know what? Bruce's colleagues that actually left the company are wanting to come back to work on this new microservice engine. And before I say thank you, I really encourage you to have a look at the new DDD by Examples project called Library that we created together with Jakub Pilimon from Pivotal. And it is a comprehensive example showing our step-by-step journey to deliver a software solution using big picture event storming, using example mapping, design level tactical event storming, including the process of choosing the right aggregate, for example, and many, many more. So please find us on GitHub. And once again, thank you very much, and I hope to see you next year. Thank you.